In the next part of the video, I'm going to go over photodetectors. These are electrical devices whose electrical properties change depending on the amount of light that hits them. I have two photodetectors here. This one right here is a photoresistor, and this one is a phototransistor. The other one that you can use that I don't have here is a photodiode. The big difference between the photoresistor and the photodiode and the phototransistor is that the photoresistor is much slower in its response to changes in light. So if your application requires sensitive detection of light pulses it needs to be fast, then you want to use a photodiode or a phototransistor. There's a really great video on this comparing these photodetectors, and I have a link in the description. For this video, I'm going to focus on using a photoresistor, and the idea is that the resistance of the device changes depending on the amount of light that's hitting it. So if a person blocks the device and blocks the amount of light that's hitting it, you'll be able to detect those changes, and you will know that a person's hand or some object is blocking the light that's hitting the device, and you can use that to trigger something in your electrical device. Alright, now I'm going to go over the basic circuit for using the photoresistors. Alright, here's a circuit for using a photoresistor. So we have 5 volts and ground from the Arduino or a power supply, and we connect the photoresistor, which is symbolized like this. This is symbolizing light hitting the photoresistor. And connected to the photoresistor is another resistor that's connected to ground. And the readout is right here. So we'll connect this to an analog input pin. I'll say A0. So this is a big difference between the digital reads of a switch, push button, or the digital output active IR sensors. But the output here is actually going to be analog. The sensitivity of the device is controlled by the value of this resistor here. So if you're dealing with low light versus a lot of high light situations, you can control the sensitivity just by switching out the resistor. Okay, so now we're going to set this up here, zoom out. We've got the breadboard, Arduino, and let's see here, photoresistor. So the photoresistor is going to get connected to the 5 volts here. We got some resistor connected to that node right here. So this is where we're actually going to be reading out the signal. Oh, actually, well, this is getting connected to ground, and this is where we read out the signal from the photoresistor right at that node right here. And again, this is going to an analog input pin. Alright, now I'm going to show you the code and what happens when I change the amount of light above the photoresistor. Here's a diagram of the circuit we have set up again. We have the photoresistor right here and a resistor here, and we're reading out from this node. It's going to A0. The analog input pin A0. And here's the code for reading out from that node. It's very similar to the switch code and the photoresist or the IR sensor code that I've shown before. We declare the pin right here. We declare a variable for storing the output from that node that's going into A0. It's called photoval. It's an integer this time because it's an analog input, not a digital signal, so it's not Boolean. And this value can range from 0 to 1023 because it's a 10-bit analog to digital converter on the Arduino. In the setup, we set the pin mode of this button pin to an input, and this line is for setting up the serial monitor. And then in the loop function, we're just continually doing reading in from pin A0 and displaying the value. So let's upload this to the Arduino. And we've got the serial monitor right here. So right now, I have two lamps that are on, and the resistor that's in the circuit is 1K ohm. So you can see the value. It's pretty low. Remember, the range is from 0 to 1023. Now, if I put my hand in front of the photoresistor, you see that it's starting to drop, and this is because the resistance of the photoresistor is changing because there's a different amount of light that's hitting it. Now, in a low light situation, let's just flick the lights off here, see what happens. Now you can see that the value that's coming, that's being read into the pin is very low, and yeah, I mean, I'm blocking it, and you are seeing changing from 3 to 0, but the dynamic range is very small with this, using this 1K resistor. But if you're in a highlight situation, like you're shining a laser right into the photoresistor, maybe this configuration would be a good fit for you. It really depends on what kind of light is around in the room, or what kind of light source you're using in your device that's shining on your photodetector. Okay, I'm going to flick these lights back on, and I'm going to switch the resistor to a 100K resistor here. Okay. And now we're seeing the readout, and it's around 800 to 900. And if I put my hand in front of it, we see it drop down to maybe value of 600 or 500 or 400, in that range, depending on how much my hand is blocking the light. So using this kind of input, you'll be able to determine when somebody is blocking the light on the resistor, and you can use that information to control something else in the device. So I've used these photoresistors for my laser harp project, and I was shining a laser beam directly onto the photoresistor, and if somebody blocked the beam, that could be detected by the Arduino, and I used that to send out a MIDI signal from the Arduino. And I have a link for that project in the description here. I just wanted to also show the low light conditions for using this 100K resistor. And now we can see here that there's a much larger change in the value in this low light condition when I'm using the 100K resistor here. So right now it's about, the baseline's around 300 without my hand blocking any of the light. And if I put my hand there, you can see this change. It drops down to about 100. So using this larger resistor would work better for low light situations. But if you're shining a laser directly into it, then maybe you'll saturate the detector, and it won't function very well for your application. The last thing I wanted to go over with the photoresistors was how to connect multiple ones to an Arduino Uno. Shown here is a schematic for connecting 6 photoresistors to the Uno. It's pretty similar to just connecting a single photoresistor. The photoresistors are in parallel, and you read out the analog signal from this node, the node between the photoresistor and the resistor here. Each one of these nodes has to be connected to a different analog input. So the issue with using these photoresistors with the Uno is that you've only got 6 analog inputs, so that you can only use 6 photoresistors. A way to get around this is you either use an Arduino Mega, which has many more analog inputs, or you use a multiplexer. which I'll go over later in this video. So this is one of the things to keep in mind when picking a sensor out. Is it an analog output or a digital output? And given that, how many pins are you going to be able to use, or are you going to have to use a multiplexer if you want to use a lot of sensors?